Okay, I know we've had trouble with audio, so hopefully this is going to be much better. Join us and we'll see. First thing we're going to look at in your notes for Introduction to Polynomial is we want to talk about what is a polynomial, and then we're going to look at a couple examples. So first thing, what is a polynomial? If you break the word down, poly means many, and nomial just means term, or terms, if it's plural. So polynomial is many terms. Honestly, we use the word polynomial for any number of terms. When we're talking about the number of terms, those are going to be things that are separated with pluses and minuses. We'll look at that in the examples. But the generic polynomial equation is this here, where you start with your highest power, and the n, the exponent, has to be whole numbers, can't be fractions or negatives as exponents, and the a sub n, those coefficients in the front, they can be whatever they need to be as long as they're real numbers. Okay? So exponents, these are your exponents up here. Exponents, no fractions or no negatives, but coefficients, the numbers in the front, can be anything as long as it's not imaginary. All right, so the degree is what we're looking for here of a polynomial is just based on the highest value of the n, or the exponent, where a sub n is not equal to 0. Basically where there's a term, right? Because if a sub n is 0, if I put 0 in front of x, it makes that term go away. All right, so a polynomial is written in standard form. Standard form. When the powers of x are arranged in descending order, meaning they go from the largest to the smallest. So both of these two examples that you see on the screen at the moment are in descending order. All right, so we're going to kind of blow those up and look at those first two examples. It's just a bigger version of what we were looking at. So example 1, first we want to say how many terms there are. Well, terms are things separated by plus and minus. So here's one up to the plus, here's another. So there are 2 terms. And we have words to go along with number of terms. When we're identifying based on the number of terms, you want to add this in your notes somewhere, please. I'm sorry it's not there. We have words for 1, 2, 3, and then anything more, 4 or more. Okay? One term is called a monomial. Monomial. Sorry. 2 terms are binomial. 3 terms, yep, you guessed it, a trinomial. And we've used these words since Algebra 1, maybe even before. Anything more than 3 terms, we just lump together as a polynomial. But basically, really, all of these are considered polynomials. All right, so back to here. There's 2 terms. Yes, please do tell the number, but also include the word. So that's a binomial. And its degree, again, based on its highest power. Degree is 2, or second. And we have words for those. So let's see if you can find a place on here that you can make a list for all of your words that go for the degree. All right? With degree, we're going to label a 0 degree, a first degree, second degree, third degree, fourth, and fifth, and then anything past that, you just use the number. Okay, but these 6 are going to have words. 0 degree, meaning it's just a number, say 3, would be called a constant. There is no variable, in other words, constant. First degree would be like y, this would be y equals. This would be y equals 2x, or 2x plus 5, or so forth. It has highest power is 1. That one we've worked with forever. It is linear. y equals x cubed, yeah, maybe plus 3. That is not what I'm looking at. X squared plus 3. Sorry about that. When it's a second degree, highest exponent's 2, then that's going to be called, you know this one, quadratic. If y equals x cubed minus 3x plus 5, it can have many other terms as long as none of the exponents are higher than 3. Third degree is going to be cubic. Fourth degree is called a quartic. And fifth degree is quintic. All right, so this would be, say, y equals 3x to the fourth plus, I don't know, 7. It could have 7x cubed minus 5y or 5x squared, whatever. But as long as nothing's higher than x to the fourth. Quintic, y equals x to the fifth minus 3x. All right? So we're going to ask you for degrees, but we also want you to tell the word. So since it's second degree, it is quadratic. It is a parabola, so we can go graph this. Those expectations are never going away. We know it does not have a stretch or a compression or a reflection, so we can find that pretty quickly. Domain for any quadratic is always all real, but the range is going to be based on that vertex, and so this one's 5 to infinity. The number of roots are how many times it crosses the x-axis. Well, this one has 0 roots. How many solutions does it have, though? It is quadratic, so we know it has 2 solutions. Since there are no roots, that means they must be imaginary. Right? You may be asked to find those in the future, but for right now, we're not going to name them. The other words that we know for roots would be zeros, solutions, and x-intercepts. All right? Okay, looking at example 2 there on your page, you've got another quadratic. We're just going to go ahead and jump and graph it. You could do that on your calculator. You could do that by hand. When we look at this, it has 1, 2, 3 terms, which makes it a trinomial. And it is a second degree still, so it is quadratic. His domain, always all real for quadratic. His range is based on this vertex. We would have to do a little math, or we could find it in the calculator. It is -6.25 to infinity. Again, those are things we know how to do already. And this guy actually has 2 roots. Both of his solutions are real numbers because he touches the x-axis twice. Okay, looking at example 3, you'll have to turn the page. There's 1, 2, 3 terms. All right, so it's a trinomial. But when you look, highest power, his highest exponent is 3, so he is third degree, which makes him cubic. Domain for this, it continues to go left and right, so negative infinity to positive infinity, or all real. And he continues to go up and down, so all real or negative infinity to positive infinity. We know he has 3 solutions, and based on the graph, we know he has 3 roots also. Again, you can graph that one in your calculator to get the picture. That's fine. 4 and 5, we're going to do these quick as well. All right, this one, there's 1, 2, 3, 4, 5 terms. We just say that's a polynomial. And he is a, looks like 4th degree, because the highest exponent I see is 4. So 4th degree, which makes him quartic. Whoops, there's a U in there. Quartic. His domain, based on the graph, he continues to go left, he continues to go right. He does have a lowest point here. His lowest point seems to be somewhere 6, 7, 8, around -9. That might not be exact on your calculator, you could check, but it would appear that it's -9-ish to infinity. And number of roots, he should have 4 solutions, and it looks like all 4 of those are real, because there's 4 roots. And the last one of these, there's 1, 2, 3 terms, trinomial again, and his highest exponent, he is a 5th degree, which makes him quintic, and his domain is going to be, keeps going left and right, so all real, and he keeps going up and down, so his range is also all real. This guy, though, he crosses once and he touches a second time, so he has 2 roots. He should have 5, so that means there's some imaginary roots about the place. This one actually, since it bounces, it repeats, so he's got 1 solution here, he's got 2 at least solutions here. It could be that there's the other 2 are repeating here, maybe it's a multiplicity of 3, or it could be that the other 2 are repeating here and it's a multiplicity of 4, would still create a bounce. Or it could be the other 2 are imaginary. Alright. As we look at this next page, all 4 or 5 of these graphs, they tell us are not polynomials, and they want to know why. Well, looking at the first one, from the equation, he's got a negative exponent. And look, it causes this gap or break in the graph. Here, he's got a fractional exponent, and it's like the graph just stops. It no longer exists past this point. Fractional exponent, there is a jump, if you will, in this, or a peak. It comes to a point, and then it turns. Again, we know a root would be the same as x to the 1/2, so that would be a fractional exponent. Does the same thing. It has a starting point, not allowed. Exponent in the denominator, that's the same as an x to the -1. Technically, it would be x minus 3 to the -1 power. All right? So it would look like that if I took it up with the 2 plus 3, but it would be an x to the -1. That creates a gap, not allowed. So what you should notice is what we were just talking about, the gaps, jumps, breaks. There can't be any holes. None of the ones we looked at had holes. But there can't be breaks or jumps. You should be able to draw a polynomial while keeping your pencil on the paper the entire time, and it should be smooth. Their domain should be all reals, always. They have the same number of roots as their degree. We've said that before. We know that from openers. And that's called the fundamental theorem of algebra. That's a new word for us, but we've used the example a long time. Last thing, factored form. Factored form, we know you had to factor in order to find those x-intercepts so that you could graph it. We know what multiplicity is from openers. We know that multiplicity is how many times a factor is repeated. And we know how multiplicity affects the graph. Even multiplicity bounces, and odd multiplicity crosses or passes through. So here we know that we've got an odd multiplicity. Here we know we've got even. Whoops, I'm not sure you can see my picture, sorry. And over here we know that it's odd. And last here it's bouncing, so that would be even. All right, I'm not sure you've got this graph in your notes, so you might want to snap a picture or stop and draw it real quick just to have an example there. All right, and that does it for today. We're going to look at using your calculator to find relative max and mins, and then doing some graphing down the road. Thanks.